As a first step, we can rewrite 8 to the x as 2 cubed to the power of x, which is equal to 2 to the x whole cubed. And similarly, 4 to the x is equal to 2 to the x whole squared. Now, plugging these into the equation, we have 2 to the x whole cubed plus 2 to the x whole squared equals to 150. Now, let us suppose y equals to 2 to the x. Therefore, the equation can be written as y cubed plus y squared equals to 150. Let's take out y squared as a common factor on the left. So we have y squared open brackets y plus 1 equals to 150. Now, we are looking for two numbers that multiply to give us 150, where the first number, i.e. y squared, is a square number, and the second number, y plus 1, is positive. Now, the factor pairs of 150 are given below, and notice that the only pair that has a square number is 6 and 25. So with this combination, we have y plus 1 equals to 6 and y squared equals to 25. And it follows that y equals to 5 satisfies both of these equations, and therefore y equals to 5 is a root of the original equation. Now, we can write y cubed plus y squared minus 150 as y minus 5, open brackets y squared plus 6y plus 30. And for this quadratic, note that the discriminant b squared minus 4ac is less than 0. So the quadratic has no real roots, and therefore y equals to 5 is the only real root. Therefore 2 to the x equals to 5, and taking log to the base 2, we get x equals to log to the base 2 of 5, which is equal to 2.32. Please comment below if you have a different way of solving this particular question. Thank you for watching, and see you next time. Bye bye.